Very simple question on this worksheet in case you guys need it because this review, you're going to have to be doing most of it at home since we're doing the project. On Monday, you will have time in class. That's just one day, really. So this is where you guys can still get the help if you need it. So for the first question, figures KLMN and figure PQRS are similar figures. So when we know that they're similar, it means that they're growing by a scale factor, which is what our standard is. And it says if Kn is equal to 6 centimeters, so start filling this information in. If Kn is equal to 6, Mn is equal to 12, Rs is equal to 48. So when we say like Kn, we're naming this side, K and N. So it's our vertex. From our vertex K to our vertex N, it's 6 centimeters. So we're filling in that side. And PS is equal to 24. What is a scale ratio from PQRS to KLMN? So first off, we could do it for both of these numbers, but since they tell us that they're similar, I only need to do it for one, and it's going to give me the same answer for the other. But what you just have to make sure that you are doing is that you're comparing the correct sides. So you see how this KN is that smaller, like angled side? That corresponds with this smaller angle side. You see, this is the longer one coming off of it. This is the longer one that's coming off it. So that corresponds with it. So the reason why I'm saying about corresponding is those are the ones that we need to compare. So we're saying then, and it says from PQRS to KLMN. So we know when we're talking about ratios, we can write it as A colon B. We can write it as A over B or A to B, as we talked about earlier in the year. So this means that we need to do the scale ratio from PQRS to KLMN. So it's from the bigger triangle to the smaller. So that means when I compare these, PS corresponds with KN because those are those smaller little angular sides. So here's KN. So now I'm just going to fill it in. Well, PS was 24, KN was 6, and it's 4:1. So that is our ratio. That is our scale factor. And it's important that you're going from the correct figure to the other correct figure. So you can write it as 4:1. You can write it as 4:1 or 4/1. Any of those would be acceptable. On your assessment, some of you wrote 1:4, which showed that you're at least doing the right numbers, but it's saying from this one to this one here. All right, so now the next one, it says the dimensions of rectangle A are 4 times as large as the dimensions of rectangle B. The area of rectangle B is 48 centimeters squared. What is the area of rectangle A? All right, so when you go to do this, we don't need to know what the exact dimensions are of this R and S. It doesn't really matter because it says that the dimensions of rectangle A are 4 times as large. So since the height of this B is R, I can represent this now as 4R. And then since the width of this rectangle is S, I can represent this as 4S. And I know then the area of B is equal to R times S because it's our length times our width. And the area of A is going to be equal to our length times our width. So 4R times 4S. And when we multiply this, that means our area is equal to 16 of RS. So that means it will be, and since the area of the smaller figure is just R times S, that means that the area of the new shape will be 16 times larger than it. Because we know that R times S, the area of the smaller figure was 48 centimeters squared. So the area of this smaller B is 48 is equal to R times S. So that means it's going to be the exact same number there with the R times S. So, but the area will be 16 times that because we grew each side by 4. So we multiplied each of our dimensions by 4, which means that the overall area grew by 16 times. So then 16 times 48 will be 768. So the area of rectangle A is 768 centimeters squared. All right, so for 3, we're just talking about if a scale factor is going to increase or decrease the size. Well, if it's increasing the size, it's just the number that you give. This has to be greater than 1. Because if the number is less than 1 and we multiply it by it, it's going to shrink it. So if it's going to increase the size, then the numbers has to be greater than 1. So we can say 5. That will be an example of something that will increase the size. Something that will decrease the size has to be between 0 and 1. It can't be 0 because if we multiply something by 0, that means it doesn't exist anymore because it's 0. So that polygon will be 0. And if it's 1, it's just keeping it the same size. So it has to be between that. So I can then say 1/2 would be something that will decrease the size. But your answer could be anything, any other number. These are just one examples of it. All right, so from here, our scale factor is 1.2. So if we want to figure out then what n is equal to, that means it's increasing in size. So 4.8, when we find our scale factor, all we do is just multiply the numbers together. So 4.8 times 1.2 is equal to 5.76. So that's what our new side would have to be. It already tells you what the scale factor is. So we're just going ahead and applying that to the number provided. And since we know that those two correspond with each other, that would be the final answer. All right, so for this one, it says create a scale drawing of a Denver city block on a grid where one unit represents 1/40th of the actual size. So that means this here is going to be equal to 40 feet because one of those units is representing 1/40th of it. So every single unit I go here in real life will be 40 feet. So when I go 2, that's 80. When I go 3, that's 120, etc. So each of these boxes, like lines of our coordinates, are going to represent 40 feet. So to figure out, well, how do we scale this down? So we have 360 by 480 feet. So each one of these lines represents 40 feet. So what we can do then is for each of these numbers is divide it by 40. By dividing it by 40, that's telling us how many of these blocks are going to make that up. Well, 360 divided by 40 is 9, and 480 divided by 40 is 12. So that means that the shape that we do, the block, the Denver city block, needs to be 9 by 12. So I'm just going to start here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how long the city block would be because each one of these blocks or each one of these line segments represents 40 feet, and 12 times 40 will give me the 480 feet that I need. And then the other way, it's going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is my other dimension. And then it says rectangular, so I don't even have to worry about doing any other measuring here. I know that they have to be the same because rectangles, opposite sides are the same. So then that will be my city block. All right, and it's 9 units by 12 units long. Now calculate the area of both the scale and the actual Denver city block. Well, our scale drawing we know is 9 by 12. So the areas are length times width or base times height. So of our scale will be 9 times 12, which is then 108 square units or units squared. And then for the actual Denver city block, our area would be 360 feet times 480 feet, which is then going to give me 172,800 feet squared. So that is the actual area of the real city block and the area of our scaled down version. How many times as great is the area of the actual city block of the scale drawing? So we can then take the number of the actual, and when it says how many times as great, we can figure that out by dividing, and those two divided will then give me 1,600. So that means that the area of the actual block is 1,600 times greater. And it should make sense because we already talked about in this question here how we could solve by knowing that we changed the dimensions of both of them by multiplying by 4. Well, that gave us a 16 times greater. Well, 40 times 40, that's what we were changing each of our dimensions by if we're going from the scale factor to the real one. Well, 40 times 40 is 1,600. So you see that's another way that we can do this as well by knowing what our scale factor is. Since we're changing both of those dimensions by that same number and our area is the same formula, multiplying them together, we could do it this way where we divide it, or we can do it, well, let's see, how are we to change in each of the dimensions? Well, each of the dimensions was changed by 40, and 40 by 40 will tell me how many times as great it is as well.